That was about the first alternative. The second alternative uses inheritance to address the same set of requirements. If you recall, this was our initial design with 3 classes. Basic ticket representing the ticket. Ticket processor responsible for printing the ticket. Ticket app coordinating with these 2 classes to get the ticket printed for the visitor. In the beginning, we had just the basic tourist attraction, and that is entry into the botanical garden. So this is how the code for basic ticket class looked like. The get ticket cost returned $10. The get description returned botanical garden as the string. Now when we introduce Palace Tour, we will not modify basic ticket class. Rather, we will inherit from basic ticket. Let's call this subclass Basic Palace Ticket. This means Basic Palace Ticket includes functionality for basic ticket as well as the Palace ticket. So the subclass will override both the methods of the parent class. The get ticket cost will return the total cost of the ticket when the visitor takes Palace entry. This is $15. Similarly, get description will return Botanical Garden Palace Tour. Let's look at Ticket App class. This class has knowledge of what visitor has requested in the ticket. So it initially declares a variable referencing the base class, basic ticket. Now based on the visitor's preference, it instantiates the appropriate ticket object. That is, it creates either a basic ticket object or a basic Palace ticket object. It then calls the print method of ticket processor, passing the base class reference. The print method remains the same. That is, as before, ticket processor calls methods to get the cost and description of the ticket object and prints the ticket. Now, depending on what the variable refers to, either basic ticket or a basic Palace ticket object, the methods of the appropriate class get called. So we did not have to change anything in print method. The same method works with basic ticket and basic Palace ticket classes. We know this concept by the name of polymorphism, a concept that allows different classes to be used with the same piece of code. This looks good. Let's move on to the next requirement, that is adding toy train ride. For this, we will derive another class. Let's call it basic toy train ticket. It will override get ticket cost to return $20, $10 for basic, $10 for the train ride. And its get description method will return a string Botanical Garden Toy Train. Hold on, did we miss something? What if visitor chooses Palace Tour in addition to Toy Train Ride? Then we need one more derived class. Let's call it Basic Palace Toy Train. It will override the 2 methods similarly. As an example, its get description method will return a concatenated string of Botanical Garden, Palace Tour, Toy Train. So it appears like the number of classes is increasing with each new attraction that we are adding. We can fully understand the impact of this design if we add one more attraction. What if tomorrow tourism department introduces a tourist guide for an additional $5? This will result in at least 3 more ticket options. One, in which visitor selects guide with palace tour. This will cost $25. Second, with a ticket cost of $30, where visitor chooses guide with a toy train. And the last one, with a cost of $35, that includes palace, train ride, and the guide. In the inheritance approach, we need to have one class for each permutation of the ticket. Going by this, our inheritance tree will look somewhat like this. So with this design, we are heading towards some sort of class explosion, and this is not a happy situation to be in. Now this is where our decorator pattern comes to the rescue, and that's exactly what we are going to discuss in our third and the final alternative.